Good morning, majors. This is Notes, Unit 4, Day 6. We're going to revisit isosceles and equilateral and now right triangles. So this first part is a warm-up. You guys will do this in class. Um, so this is our fifth and last part of congruency, and it's called hypotenuse leg congruence. So before we've looked at side, side, side. If all three sides of a triangle are congruent to the other triangles, all three sides, then we can prove that they're congruent. If we have two sides and the included angle, then it is congruent. If we have two angles and the included side, ASA, then those are congruent triangles. And our last one was angle, angle, side, right? Two angles and then the next side. We have the ones that are not congruent are going to be if all three angles are congruent, that doesn't prove that we have congruent triangles. And if we have side, side, angle, that does not prove that our triangles are congruent, right? Our last one today is going to be hypotenuse leg. This is specifically for a right triangle. Underline that word right triangle right there. If the hypotenuse, remember the hypotenuse is the side that is opposite the 90-degree angle. So this is your 90-degree angle, and my biggest side, or the side opposite that 90-degree angle, is always going to be my biggest side. That is AC. And then the biggest side of this 90-degree angle is DF. These are our hypotenuse. And then the leg. It doesn't matter which leg. It can be the long leg or the short leg. In this one, they tell us the short leg, BC, is congruent to the short leg, EF. And we have a 90-degree angle in both. Then we can prove that my triangles are congruent by hypotenuse leg congruence. They have to be a right triangle, right in there, right triangle. It's very, very important. All right, the congruent statement, remember we're going to put them in order. Triangle, they started us off, A, B, C, it's congruent to triangle. A is the one with the blue mark, the blue congruency side, and then no mark. So we have blue and none, and that's going to start with D. We need to start with D. Then we're going to go to B, which is my right angle. My right angle in my right triangle is E. And then I went from D to E. My last one is going to be F. DEF. We're going to work on another proof. We're going to just keep on going over proofs, getting as much practice as we can. We're trying to prove these two triangles are congruent in this order. So our last step needs to be triangle MNQ is congruent to triangle QPM. And my reason is going to be one of these 5 congruencies. Side, 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 angle, 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 side, or HL. Probably HL because that's our new one. And we usually do one of the new ones first. So I'm going to mark up my triangles. The given is already in the triangles. They don't actually have it written up here, but I can still assume they're congruent if they have a congruency mark. So MN is going to be congruent to PQ because they each have one congruency mark. And I'm going to write that down here. MN, side MN, put a line above it, is congruent to side PQ, put a line above it. And my reason is they're giving it to us. They have that congruency mark. So that is given. We always start with the given. Almost always. 99% of the time. Now, we're also given that this is a 90-degree angle, right? And this is a 90-degree angle, which means our P and N are congruent, and we have a right triangle. So we're going to say angle N and angle P are right angles. And that is because they give it to us. It's given. So we have right triangles, and we're given these two are congruent. There's one more thing we can assume is congruent, and that is this side right here, because they're sharing it. So this is MQ is congruent to itself. Put a line above it. Those are both a side, same side. And since they're sharing it, it's the same side. We're going to say that it's the reflexive property. Okay. Now we can prove these triangles are now congruent. But we need them to be right triangles. They need to be right triangles. If N and P are 90-degree angles, can we prove that these are right triangles? We can. So we're going to say triangle M N Q and triangle Q P M are right triangles. And that is because we have a 90-degree angle. That is the definition of having a 90-degree angle. Or we can say a definition of a right triangle. That's a definition. We have a 90-degree angle, and that's a definition of a right triangle. We'll go over that again in class. Now, I can prove that my triangles are congruent, and I put them in order just like they did here, and it's going to be because we have a right triangle, and we have a hypotenuse, and we have one of the legs. So we're going to say because of the HL postulate, or you guys can put congruence, I don't care, whichever one you want. Alrighty, go ahead and flip your paper over. It says isosceles triangle. Remember, isosceles triangle has two congruent sides. We already went over this. And my opposite angles are congruent. This is very, very important. So it says if two sides of a triangle are congruent, then the base angles are congruent. The converse means we're going to flip it. And we did this for our notes. It says if two base angles are congruent, then the sides are congruent. Alright guys, so if AB and AC are congruent, then my opposite angles, angle B, is congruent to angle C. You guys can do the next one. It says try these, solve for each angle. So we have x, 6x, and this side is equal to this side. So that means the opposite angles have to be equal. So if this one is x, this one is also x. Remember, we have to add them up and set them equal to 180. Angles of a triangle add up to equal 180. So I have 1, 2, plus 6 is 8 x's. Divide by 8 on each side, and you're going to get x equals a number. So if you divide by 8, I think I got a decimal. I hope that's right. 22.5. Oops. 22.5. Try the next ones, guys. This one was number 2 was very similar to our quiz. All right, number 3. We have these two angles are equal. So we can assume that the opposite sides are equal, and we're actually the number 17 is a distractor, so cancel it. Cross it out. And we're going to say 2x plus 1 has to equal 15. Solve for x. Remember, an equilateral triangle has equal sides. Equilateral means sides. All the sides are equal. And all of the angles will be equal also. And a triangle is equilateral if it has 3 equal sides. If a triangle is equilateral, then it is equal angular. If it is equal angular, then it is equilateral. Make it a biconditional. It's not how you spell equal angular. I want you guys to write the biconditional down here. And then when you come to school tomorrow, we will focus on more proofs. Have a great day, Majors.